Hello, this section we're going to be doing today is segment lengths in circles. The last unit we did angle measures with circles. Now we're going to do segment lengths. This is the 5th section of Unit 9. Let's get started. All right, we have something we saw last time. Last time we used this, we actually tried to find the lengths of these, or the measures of the angles. Well, today we're going to be doing the lengths of the segments, and there are some relationships with these segments, and let's talk about them. It says here you have two intersecting chords. What is the relationship between the lengths of their segments? The relationship with the length of those segments are that the little pieces multiplied together equal the pieces of the other one multiplied together. So we have EC, that's this section right here. If we multiply that by AC, those two multiplied together will equal this one times this one. I want to remind you that this is on your Formula Madness. Another property that's translated, it's actually one of your theorems that you're going to have in your term book or your postulate book. You have two intersecting secants. What is the relationship between the length of the segments? I want you to notice that these segments here, you have some on the outside and some on the inside. This is the relationship. You have this piece on the outside, AB. If I multiply it times the whole piece on the outside, AC, that will equal this AD on the outside multiplied by the whole AE. So in summary, it is the outside times the whole will equal the outside times the whole. This is on your Formula Madness also. Let's talk about another one. This time we have a secant and a tangent. You have a secant and a tangent. What is the relationship between the lengths of the segments? Last time we had an outside times the whole, but this time we don't have an outside. We only have an outside, and the outside and the whole are the same thing. This particular piece over here has an outside and a whole. So let's see how that all translates out. This time, that outside and that whole that we have over here, since it's one and the same, it seems logical to me that we would just multiply it times itself. And then we have the BC, and that's times that whole piece on the outside there. So this translates that we have the outside squared, that's that tangent, equals that outside piece multiplied by the whole. Okay? Again, this is on your Formula Madness. Now, so what I'd like you to do is, as we're doing this, as the video pops up, and as these things pop up, I want you to actually pause the video and try to figure out the answer. And then turn it back on once you have it and see if you got it right. We're going to do geometry, fact, or fiction. So I want you to tell me if this statement is a fact or a fiction. X times 18 equals 12 times 21. Pause the video, come back if you've decided, when you've decided. Now, welcome back. When we did this one, if you remember, the theorem of property said that if you multiply this one times this side, that should equal this side multiplied by this side. So it should say x times 18, which is, this is true, should equal 12 times 9. Not 21. 21 would be 12 plus 9, or the whole. So this was fiction. This was not true. This was fiction. It should have been x times 18 equals 12 times 9. And to solve that, we would just divide this by 18 on both sides, reduce, and we'd have our answer for x. When we multiply those together, divide by 18, we get 6. All right, let's do another one. If you remember this one, look back at the properties on your postulate book. We're going to decide if it's fact or fiction. When I bring this up, you're going to actually pause the video, see if you can figure it out on your own. Come back when you figured it, if it's a fact or a fiction. Is this a fact or a fiction? Pause the video, come back when you're ready. Welcome back. The property said that if I multiply the outside times the whole, which would be 11, there's our 11, and 10 plus 11 is 21. So yes, we have 11 times 21. And then we'd have our outside piece, which is 12. Yep, there we have it. And the outside piece is going to be x plus 12. And we have it. This was a fact. This was a true statement. It was a fact. To find x, we're going to need to do the distributive property and multiply these together. When we multiply that together, we get 231. Multiply that out with the distributive property, we get 12x plus 144. We're going to move this 144 over here by subtracting, and then we're going to divide by that 12. If I'm going too fast, pause the video and work on it as you're going. Don't let me dictate how fast you need to go. You have the ability to pause this video and do this on your own. And you divide by that 12, we should get a fraction, 29 over 4. Let's do another one. I want you to look at your property about this. Decide if this is a fact or a fiction. I want you to come back when you have figured that out. Welcome back. If you remember, we had an outside times the whole, but for this particular one, the outside and the whole were the same, and so we were supposed to square this. And then we have the outside times the whole, and the outside and the whole here, the outside is the x, but the whole is x plus 24. So this should have been totally different here. This is a fact. It's just definitely not a fact. It is fiction. It should have been 5 squared. That would have been this piece out here. And then x plus 24. Whoa, is this a fiction again? Is it really x times 24? No, it's another fiction. It should be the outside piece times the whole, which is the x times 24 there. Now, the rest of this is going to be solved a little differently than you will see on your homework this time. But this is an advertisement for something we're going to do next lesson or next day. So I want you to pay close attention. This is a review from Algebra 1. And I want you to remember this. You will not have some on homework like this one, but this is an advertisement for next time. You will have problems like this one, but you won't have to solve them in quite this manner. But I want you to pay attention because this is an advertisement for something we're going to do next. we're going to do the distributive property of this right here. All right? We're going to do that on the next slide. Here we go. Again, I brought this up. We're going to do the distributive property. I want you to pause this and actually do this distributive property right here. Come back and check your answer. I got 25 equals x squared plus 24. I did that by multiplying out the 5 squared. That became x squared, and this became 24x. This is a different kind of equation. We now have an x squared and an x, and we can't solve this in the normal manner. This is called a quadratic. We have to do something different. So what we need to do is move the 25 over to the other side and set it equal to 0. So we will have 0 equals x squared plus 24x minus 25. We need to solve this in a different way than we've done before. We can't just move everything to one side and divide the end. We have to do something called factoring. We need to set this in parentheses and find out what's multiplying together to equal this. When I taught this in Algebra 1, I used the box method. Some of you might have seen this before. The box method looks like this. All right, I take this x squared part and I figure out what goes in there. What times what equals x squared? And it's x and x. And then I take the negative 25 and I multiply it together and see what multiplies there. There are multiple things that do this. 5 times 5, one of them has to be a negative to make the negative 25. Another thing is 25 and 1. One of them needs to be negative, but not both, okay? So that I can get a negative 25. The trick is, when I stick them in here, I'm going to have to make sure that I can get the 24. And let me show you how we do that. We're going to do this one. One of them has to be negative. I'm going to put in the 25 and the 1, and to get the 24, one of them is going to have to be negative. And which one is it? Let's just pick one and see if we can do this. We're going to put that one there. And to get that 24, we're going to do the diagonals. That diagonal is negative x. This diagonal is 25x. I am going to add them together and see if I get the 24 that I'm looking for. And notice that I need to erase some stuff so I can see it's actually a positive 24 that I'm trying to get. And so let's see if that worked. When I add these two together, I will get 24x. So yes, I have found it. There's a lot of stuff on this page, so let's get rid of some stuff so we can simplify here. We noticed that I got what I wanted for that centerpiece. So here's how we're going to do that. This is one of my factors. X, it's a positive 25, so we're going to say plus 25, and x minus 1. The 0 property, these two things equal 0, so the 0 property tells me that if something equals 0 and it's multiplied together, then each piece, x plus 25, has to equal 0, and x minus 1 has to equal 0. So I ask myself, or I solve by subtracting the 25 over, I ask myself what plus 25 gives me 0. That will be negative 25. And what minus 1 gives me 0? That will be a positive 1. We technically could have two zeros, but should be two answers. But let's go back and look at what our original problem was about. We were actually trying to find the value of x. And x is a physical length. My two values were x equals negative 25 and 1. I cannot have a negative 25 in that length. So my answer is x equals 1. I want to reiterate that on tonight's homework, You will not have a quadratic to solve, but you will have to set up an equation and solve it, but it won't be a quadratic. This was a advertisement for something we're going to do in a couple of days. Let's move to the next thing. Let's do some of your homework problems together. We're going to do 1 through 11 odd. All right, open up your homework pages. I'd like to challenge you on this. I'd like to challenge you to actually do some of these problems before I do. So pause the video and see if you can figure it out, and then come back and check it. We are going to do this one by remembering the property that if I take each of these individual pieces and multiply them together, then the lengths of the other ones multiplied together will be equal. So we'll have 24 times 18 will equal 16 times x. You can multiply that out and write it, but you don't have to. I'm just going to divide by the 16 and have x equaling this. You can put that into your calculator and be done, or you can reduce some of this. I'm going to reduce because I like doing it in my head and having practice. I know that 4 goes into this one and this one. 4 goes into this one. Actually, 8 goes into both of them. 8 goes into this 2 and 3. And 2 goes into 18 9 times. So I'm going to have 27 as my answer. Let's check it to make sure. Yep, 27 is correct. We're going to move on to number 3. This one is the same concept. It's just got letters instead. So I'm going to challenge you. Pause this. Come back when you're finished and see if you got the right answer. We're going to do the same thing. We're going to multiply the 3x times 10. And that should equal the 3x plus 2 times 9. Make sure you put a parenthesis so that you can do the distributive property. So that's what I'm going to do here. I'm going to do that distributive property. And multiply that out. So I'll have 30x and I'll have 27x plus 18. I'm going to move that over here by subtracting, and I'll get 3x and the 18. Divide by 3. X equals 6. Yes, the answer is 6. Let's go on to number 5. Number 5, we've saw before. This one has the two secants. Remember the property for this one was the outside times the whole equals the outside times the whole. So that means we have 7. The whole here is the 7 plus x. And that will equal the outside, which is the 6. And the whole is 8 plus 6, which is 14. Again, I want to challenge you to pause this, come back when you're done, and check your answer. We're going to do the distributive property here, and I'm going to get 49 plus 7x equals 84. I'm going to subtract that 49 over. And I get 35 and 7x, divide by 7, and x equals 5. And 5 is the answer. Let's do number 7. Again, we have the same kind, except now we have more variables. And so I want to encourage you to pause this video, come back when you have an answer. We have the outside times the whole and the outside times the whole. So the outside is the 4. The whole thing is 4 plus x plus 2. That should equal the outside of the other one, which is 5. And the whole thing is 5 plus x minus 1. I'm going to simplify this before I do the distributive property. So I have a 4 on the outside. This on the inside here, will 4 and the 2 will come together as a 6 plus x. And over here, the 5 and the negative 1 will come together, and I'll have a 4. Now I'm going to do the distributive property, and I'll have 24 plus 4x equals 20 plus 5x. I am going to bring the 20 over here by subtracting and get a 4. And I'm going to bring the 4x over there and get a 1, or 1x, or just x. Let's check our answer. 4 is our answer. Let's move on to number 9. Here we go. This one doesn't have two secants. We've got this tangent here. So our tangent, we don't have an outside and a whole. So we're going to just do 30 squared. But this time we do have an outside and a whole. So our outside is 18, and the whole thing is 18 plus x. 30 squared is 900. I'm hoping that you're checking your answer right now and not just blindly writing this down. I hope that you're actually checking your answer after. You'll get way more out of this if you do. 18 times 18 is 324. And then 18 times x is 18x. I'm going to move that 324 over. And I'll get 576. And that will equal my 18x. I'm going to divide by that 18. And I get x equals 32. Let's check our answer. It just has more variables. I want to encourage you to do this problem and then come back. If you get stumped, come back, or if you want to check your answer, come back. Let's do this together. Remember that we have to square that. So we're going to have x plus 8 squared. Then I will have the outside times the whole. So let's try that. This is x plus 2 times x plus 2 plus 15. I'm going to simplify this first. At the same time, in the next step, I'm going to multiply that out. Now, I want you to be cautious when you multiply that out. Let's simplify this side first, and then we'll talk about that. So over here, I'm going to have x plus 2. And this 2 and 15 are going to add up to 17. So I'll have x plus 17. This x plus 8 squared means this. It means x plus 8 multiplied by x plus 8. Some of you know a shortcut. Whenever you have a squared, you can do a shortcut. But if you don't remember the shortcut, that's okay. You can just do the distributive property 2 times. When that happens, you're going to have an x squared. You're going to have an 8x. You'll have another 8x. That's the trick. That'll always be a doubled here in the middle. Same thing twice in there. And then you'll have this, which is just 8 squared. which is the 64. So you'll have x squared plus 16x plus 64. And that just goes right up in there. I'm going to actually make this go away a little bit smaller so that it doesn't take up so much room. All right, here we go. We need to multiply this out. I will have x squared plus 17x plus 2x, and 17 times 2 is going to be 34. And then I'm going to bring this thing down. Right there. Now, a little bit ago, I told you you're not going to have one of these problems on your homework. These quadratics, these x squareds. Now, you don't have a quadratic because I am going to subtract x squared from both sides, and those will go away. I will be left with 16x plus 64, and these two can simplify together to be 19x. So let's do that, and then we'll move things around. So we'll have 16x plus 64 equals 19x plus 34. I am going to bring, no matter what I'm going to do, I'm going to get a negative. No, I won't. If I bring this over there by subtracting, I'll get a 3x. And if I bring that over by subtracting, I'll get a 30. Divide by 3, x equals 10. All right. The trick to this one is not only do you have to set this up correctly, but when you square it, you have to do all that. And when you multiply this out, you need to make sure you do the distributive property 2 times. Let's check our answer. We got 10. All right, let's review what we've learned. We just did 3 new theorems, which was 3 more formula madness questions. We studied the relationship between the lengths of intersecting chords, secants, and tangents. I want you to notice the difference. Last time we did angle measures. Today we're doing lengths of intersecting lines and line segments. Next week, I want you to bring a statement that is about you, that is either a fact or a fiction. I want you to bring a statement about yourself that's either a fact or a fiction, and we're going to try to decide if it's fact or fiction. I hope this has been helpful. Goodbye.